All right, guys, I want to just give you some examples of some different types of limits, either using the properties or not using the properties. Again, the properties are just kind of there for you to have understanding of how they will work. There's not very often that they will come up. The properties are most important if you've got two different graphs that you're looking at and it's not an explicitly defined function. But most of the times we're just going to roll with what we've got. So let's say I've got the limit of, say, x squared minus 36 over x minus 6. And I want you to find the limit as x approaches 1. That'll pause there while you figure that out. But we will have done a direct substitution if possible. So we will do 1 squared is 1 minus 36 over 1 minus 6, which will give me negative 35 over negative 5, which is no problems, which would be 7. Okay. What would be the, oh, you hear the thunder? It's Friday, actually, when all the thunder and lightning and storms have been coming through, so that's what day it is for me still. Okay, so this one will be for you to do. And again, it'll pause and you'll answer it. So if you try to do a direct substitution, you should have gotten 6 squared minus 36 over 6 minus 6, which would have been 36, 6 squared is 36, so you'd have gotten 0 over 0. 99% of the time, if you end up with a limit of 0 over 0, it means that the limit does exist, and you have to figure out what it is. So what you should have done was factored the x squared minus 36 into x plus 6 times x minus 6. You should have reduced this on down to just be x plus 6. Actually, let me use a different color for that. All right. Then we would have reduced this on down to just be x plus 6, which meant there was removable discontinuity at x equals 6. And now I will find the limit as x approaches 6. No problems now with evaluating through substitution. So I'll get 6 plus 6, which is, of course, 12. How'd you do? I hope you did well. Okay, so then let's do, we have something like the limit of x plus 4 over 2x squared plus 9x plus 4, and we'll let x approach negative 4 on this one. Okay, so again, I'm not really using the properties, kind of am, kind of not. For that one, if you had done it through a direct substitution, which should always be your first approach, you would get a negative 4 plus a 4, which is, of course, 0. But don't just think it's 0 and move on, because if it's not, you'll have a problem. Negative 4 squared is 16. 9 times negative 4 plus 4. So you have 0 in the numerator. And then in the denominator, you'll get 32 plus negative 36 plus 4. That also ends up being 0. Again, 99% of the time, that does mean that the limit does exist. So I'm going back to the original problem. And hopefully that denominator is factorable, which it is. It's factorable into x plus 4 and 2x plus 1. Which is nice because then, of course, I can reduce out my x plus my 4s, and I'm left with 1 over 2x plus 1. And then I reattach my limit. It's important, it's always important to speak clearly, especially if you're going to move on to calculus. You want to always be able to communicate proper math. So do keep yourself in the habit of writing the limit again before you just write equal sign, because otherwise it's like using bad math grammar. All right, so this will be 1 over, no problems now with substitution, so 2 times negative 4 plus 1, and that'll be negative 1/7. Did you get that one? I hope you did. Okay, moving along. Give you a more complicated one. Let's do something like limit. You had some of these in your worksheet, so this should pretty much be basically a review. This week shouldn't be too bad. Honestly, limits really aren't too bad in general. The basics that we do, the introduction to it, really isn't bad. All right, so again, direct substitution would bring you to 1 over 0 plus 1, which is 1, over 0. Big red flag, 1 minus 1, so 0 over 0. So again, the limit probably exists. We just need to figure out what it is. So whenever you have this type of a scenario, the way you want to simplify this on down is you want to try and basically get rid of the compound fraction piece. Compound fractions are fractions that are in fractions. And the easiest way to do it is to multiply by a carefully chosen value of 1. So I would see that the common denominator of all the denominators that I have is x plus 1. So I would multiply everything by x plus 1 over x plus 1 because you haven't changed. I mean, that's really technically a fancy 1. So then when I distribute x plus 1 to the first piece, that would just be 1. And then I'll distribute x plus 1 to the second piece, and that'll be 1 times x plus 1, so that's just x plus 1. Be careful with your minus signs though. I'm gonna leave the denominator as x times x plus 1 because I need to be able to reduce something. When you do distribute the denominator, when you distribute the numerator, the minus sign, and combine like terms, you'll be left with just a negative x in the numerator. Again, the goal is I'm trying to reduce something out so I can find this limit. The x is now reduced. So I'm left with a negative 1 over an x plus 1. And don't just write, like if you just come here and now write equals negative 1, that's a bad, that's bad grammar because there's no way that that equals negative 1 all on your own. It's the limit as x approaches 0 of that thing that equals negative 1. Now, good grammar, we're good. What color was I wrapping around? I guess the pink. Okay. All right, so I'll give you one to try on your own, and then the video will pause and have you test it out, see how you're doing. Let's do the limit of 1 over x minus 8. Plus 1 over 8 over x as x approaches 0. Pausing so that you can see it. Okay, if you just plugged 0 in right away, which is what you should have done, you would have gotten 0 over 0. So then you want to simplify this on down. And the common denominator between the denominators, which the only denominators are the x minus 8 and the 8. So that would be a 8 times an x minus an 8. And I will multiply that by this carefully chosen value of 1. When I distribute this to my first term, the x minus 8's reduce, leave me with just an 8. When I distribute this to the second term, the 8's reduce out, leaving me with the x minus the 8. I'll have to really be as careful because there's no subtraction sign to have to distribute, but that's okay. All right, so then this will become x over 8x times x minus 8. The x's then can reduce, leaving me with 1 over 8 times x minus 8. And then again, you've got to bring down that limit because you can't just write that this thing is equal to whatever the limit is because that's bad grammar, it's bad math grammar. Now you can plug in your 8 and this should be equal to negative 1 over 64, and that's what you should have gotten for your answer. How'd you do on that one? I hope you did wonderfully. Okay. A couple more here and then we'll call it a day. Call it a, not necessarily a day, but call it a video. Alrighty. Okay, so again, you guys always have your calculators with you since you're at home, but keeping in mind that if we were still in school or if you were in calculus next year, this one would be one that you know, might have to be a non-calculator question. So if you were to do this one, you would get cosine of 0, which is 1, over the sine of 0, which is 0. You would get 0 over 0. So again, 99% of the time, that means that the limit exists. Okay, so then from here, you got to multiply by a carefully chosen value of 1. And so usually when you have something where it's not really a conjugate because we don't have square roots and conjugates really go to squares, but it's kind of a conjugate. So the numerator has something being subtracted there. So if I multiply by the quote unquote conjugate of that numerator, I can multiply by cosine of x plus 1 over cosine of x plus 1 because I have to multiply by 1. Otherwise, I've changed the problem. So don't change your problem. Then the numerator will give me, you have to distribute everything. So I'm going to FOIL out the numerator. I'm not going to FOIL the denominator because, or multiply the denominator out because I'm trying to get something to reduce. So the denominator is going to stay as the sine of x times the quantity cosine x plus 1. Again, because I'm trying to get something reduced. But the numerator will become cosine times cosine, which is cosine squared. Cosine times 1, which is cosine. Negative 1 times cosine, which is negative cosine. And then negative 1 times 1, which is negative 1. So the numerator becomes cosine squared of x minus 1. Now, I hope that you have not forgotten your identities from the last quarter. So one of those identities, the Pythagorean one that you really need to always have in your head is the fact that sine squared of x plus cosine squared of x will always be equal to 1. If I rearrange that, I move the 1 to the left side, that would give me cosine squared of x minus 1, which means that that's really equal to negative sine squared of x. I'm going to use this information right here to replace the cosine squared of x minus 1. So that'll become negative sine squared of x. And the denominator will be sine of x, leaving this again because I'm going to successfully reduce something out here. So now I can reduce out a sign in the top and the bottom, which leaves me with a negative sine of x over cosine of x plus a 1. All right. So now back to my limit. So limit, it's technically, it looks a little different. It's not really simplified. It's just, it looks different. So it's probably going to be helpful for us. All right, so now I'm going to try and evaluate this through a direct substitution of evaluating the 0 or plugging in 0. So sine of 0 is 0. So I don't need to really write the negative. So already I'm a little bit nervous. All right, cosine of 0 is 1. This is 0 divided by 2. All right, so as long as it's not 0 divided by 0, no issues. 0 divided by anything is always going to be 0 unless that number is 0. So that limit came out to be 0. All right, so one for you to try. All right, that one's for you to try. Don't be fooled. Okay, so upon initial investigation, cosine pi over 2 is 0. Sine pi over 2 is 1, 0 over 0. Again, usually that means that the limit exists. Not always, but usually. But hopefully you've already come to some kind of a scenario where you're like, I'm questioning this one, and I hope that that is something you are questioning. So this one comes out weird because when you do the 1 plus sine of x, and again, I'm going to make this, going to leave the numerator. I don't want to distribute this into the numerator because I'm trying to reduce. 1 minus sine times 1 plus sine would be 1 minus sine squared. Hopefully you replace the denominator of 1 minus sine squared with cosine squared. So that's what I'm about to do. So I'm going to replace that with cosine squared. I'm going to reduce out a cosine from the top and the bottom. So I'm left with 1 plus sine over cosine. Limit now as x approaches pi over 2. Again, remember, you cannot not write that limit again when you go to do the evaluation. It won't make sense. It's bad math grammar. All right, sine pi over 2. Sine pi over 2 is 1. Cosine pi over 2 is 0. Okay, this is not 0 over 0 anymore. This is just an undefined scenario. So what this means is if you would graph this in your calculator, you would see a vertical asymptote right here. And remember, if the limit is not approaching a specific number, the limit doesn't exist. So this is one of those times when even though you had 0 over 0, and I say, 99% of the time, usually that means that the limit exists. In this scenario, it doesn't. I'm so sorry. All right, so a couple of piecewise defined ones, and then we'll be good to go. All right, so let's take, and again, you had some of these in your practice, but still gonna do it. All right, so let's say that f of x is the piecewise function 3x minus 2 when x is less than 2, and 8 minus x squared when x is greater than or equal to 2. And I'm going to ask you, what is the limit as x approaches 2 of f of x? So your first approach would be to just plug it in. However, when it's a piecewise defined function and that the point at the value that you're looking at is where you're going to jump from one part of the function to the other part of the function, well, then you've got to be very, very careful. So this one, you actually have to do one-sided limits. So remember, one-sided limits means you're going to take the limit of the function and you're going to do it as x approaches 2 from numbers that are smaller than 2. So where you're going to do your substitution for that is into the first part, because 3x minus 2 is for numbers that are smaller than 2. So I am going to plug 2 into the first part, which means I'm going to have 3 times 2 minus 2, which would give me 4. Then I'm going to do the limit of the function f of x as x approaches 2 from the right. And now I'm looking to approach 2 from numbers that are larger than 2, which is the second part of the piecewise function, the 8 minus x squared. So I'm going to plug 2 into the second part of the function, which means I'm going to have 8 minus 2 squared, which is also 4. Because we're going to the same spot, I can be like, oh, cool, the limit would be equal to 4. If those two numbers came out differently, which they did in one of the practices you guys had last week, if those numbers come out to be different, then the limit wouldn't exist. So now one for you to try. And then we'll call this one g just for something different. So g of x, we'll have it be a piecewise defined function, x squared minus 4. When x is less than or equal to 3, x plus 3 when x is greater than 3. And surprise, surprise, I'm going to have you find the limit of g of x as x approaches 3. Okay, I hope you got it. Again, you'd have to do the limit from the left and the right-hand side. So I'm going to do the limit as x approaches 3 from numbers that are smaller than 3, which means you should have gotten 3 squared minus 4, which is 5. Then you should have gotten the limit as x approaches 3 from the right, which would have been plugging into the part x plus 3, which would have given you a value of 6. Those two values are not the same, in which case this limit does not exist. The limit does not exist! The limit does not exist. Alrighty, guys, hope you're doing great. Miss you.